Hello everyone. In chemical engineering thermodynamics, uh, we are discussing constant volume process, constant pressure process. We are already discussing, and we get the relationship between Cp and Cv. So in previous lecture, we discussing the constant pressure process. Now let us complete uh, today's lecture. We are discussing the relationship between Cp and Cv and constant temperature processes. So example number 3.2 is that in which show that Cp minus Cv is equal to R for the ideal gas. So this condition we have to satisfied. We have to prove. Okay. So Cp minus Cv equal to R for ideal gas. Cp, that means constant pressure, and Cv is constant volume. So let the solution define. Enthalpy is defined as a enthalpy को हम कैसे define कर सकते हैं? Enthalpy is defined by H is equal to U plus PV. We know that the enthalpy is given by this equation. H is equal to U plus PV, internal energy and product of the pressure and volume. So therefore the difference at any point. Okay, so dH is equal to du plus d into PV. So we know that for the ideal gas PV is equal to RT. We know that PV is equal to RT. That condition we have to use. So right now we are using PV की जगह पे RT लिखेंगे. So that is similar DH. So PV ની જગ્યા પર RT put કરવાનું છે. So for the ideal gas PV is equal to RT. So DH is equal to DU plus RT. So R is a constant and temperature is a variable. So R is constant and difference change in temperature, that is dt. Now in this equation we are putting the values of dH and du. Okay, from above equation जो स्पेसिफिक वैल्यूज है वहां से हम dH और du की वैल्यू हम पुट करेंगे. So substituting the equation 3.16 and 3.11 into the above equation and we obtain that dH की जगह पे CpDT and du की जगह CvDT. Okay, so plus R is constant into dt. In each and everywhere dt is common. Okay, यहाँ पे भी dt है और यहाँ पे दोनों में dt है, तो dt को हम कॉमन लेंगे तो क्या हो जाएगा? dt will be cancel. Okay, so remaining term is Cp is equal to Cv plus R. So R is equal to Cp minus Cv. Okay, so this equation is satisfied. Condition is proven that Cp minus Cv is equal to R. Now नेक्स्ट कांस्टेंट टेम्परेचर प्रेशर. जैसे हमने कांस्टेंट वॉल्यूम कांस्टेंट प्रेशर प्रोसेस देखा, उसी तरह कांस्टेंट टेम्परेचर प्रोसेस को देखना है. व्हाट एग्जैक्टली हैपन इफ आवर टेम्परेचर इज कांस्टेंट ड्यूरिंग द प्रोसेस? ओके, एनी चेंज इन प्रोसेस और नॉट? सो एग्जैक्टली internal energy of ideal gas will change only if the temperature changes. Okay, internal energy of the any process or any gases is changed when we are increase the temperature or changes the temperature, but in case of temperature is constant. So in isothermal process involving an ideal gas, the change in the internal energy and the change in the enthalpy would be zero. Okay, so during constant temperature processes, change in the internal energy and enthalpy, internal energy U du is equal to q minus w. Okay, U is equal to q minus w, and enthalpy H is equal to U plus PV, all must be 0. So put du equal to 0 into equation number 2.5. At that equation dw dq is equal to d minus du is equal to dq minus dw. Okay, ये इक्वेशन हमने देखा था. du equal to du is equal to सो ये इक्वेशन हमने देखा था du इंटरनल एनर्जी फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स du is equal to dq minus dw but in condition of that कि internal energy and enthalpy would be zero that means du की जगह पे क्या हो जाएगा जीरो सो रिमेनिंग टर्म क्या हो जाएगा ये इक्वल टू की दूसरी साइड जाएगा तो दैट मीन्स dw minus dq is considered. So give the equation number 3.13. Next, the above equation can be integrated to determine the heat and work effect in isothermal process involving ideal gas. આ ઇક્વેશન નો યુઝ કરી અને આપણે ઇન્ટિગ્રેટ કરી શકીએ છીએ અને એના દ્વારા આપણે શું કરી શકીએ છીએ હીટ અને વર્ક ની અંદર આઇસોથર્મલ એટલે કોન્સ્ટન્ટ પ્રોસેસ પર કોન્સ્ટન્ટ ટેમ્પરેચર પ્રોસેસ પર આપણે હીટ અને વર્ક ફાઇન્ડ કરી શકીએ છીએ. સો let the integrate this equation. So q is equal to what exactly? Q is equal to w is equal to integration of p into dv. बराबर वर्क is equal to p into dv. So p की जगह क्या रखेंगे हम pv की जगह पे rt लिखेंगे so q is equal to w is equal to rt into इंटीग्रेशन करना है 1 अपन p का 1 अपन ln हो जाएगा सो दैट इज p इंटू dv. सो pv की यहाँ पे क्या आ जाएगा rt ln v2 अपॉन v1. ओके, गिव देम द इक्वेशन नंबर 3.13 where v1 and v2 are the initial and final volumes of the gas in an isothermal process and let p1 and p2 be the pressure in the initial and final stage. So respectively, then the ideal gas equation leads to following relation. Initial and final case of volume, gas is in isothermal positions. So let be P and P1 with the pressure and V1 and V2 which are the volumes. So relationship between the volume and pressure would be V2 upon V1 is equal to P1 upon P2. So substituting this equation 3.15 into 3.14 v1 and v2 ની વેલ્યુ અહીંયા મૂકવાની છે આપણે. So the equation can be written as a q is equal to w rt ln v2 upon v1. It should be taken as a rt ln p1 upon p2. Both equation we can write. So this equation is said the constant temperature processes. Now next theory is that adiabatic processes. What is adiabatic process? So adiabatic process in which there is a no heat interaction between the system and surrounding, dq is zero equal, so it is called adiabatic process. That means adiabatic process, it means there is a no heat is interact between system and surrounding. dq की वैल्यू क्या होगी जीरो, इसे क्या कहेंगे हम adiabatic processes. So du is equal to minus dw because du is equal to what happened, d is equal to dq minus dw. We know that the first law of thermodynamic mathematical statement, dq की वैल्यू क्या होगी जीरो, तो रिमेनिंग टर्म क्या हो जाएगा dw. सो माइनस dw वर्क की जगह पे हम क्या लिख सकते हैं p इंटू dv. ओके, p इंटू dv. सो एज पर द adiabatic process the final equation du is equal to minus dw equal to minus p dv. So minus minus will be cancelled. So that means for an adiabatic reversible process, later in this section it is shown that it is adiabatic process, the pressure and volume are related with PV raised to gamma is equal to constant. adiabatic reversible process માટે કે એની અંદર આપણે શું ડિસ્કસ કરવાના છે, PV raised to gamma એ શું છે કોન્સ્ટન્ટ, અને જે gamma ની વેલ્યુ શું હશે CP by CV. ઓકે, which is assumed constant for the ideal gas, and it is already proven that Cp minus Cv is equal to R at a constant. बराबर, R is the gas constant. If the ratio of the difference between two quantities are constant, then quantity themselves should be constant. So the assumptions of constant gamma implies that both Cp and Cv are constant. So for the common manometric diatomic gases at a low temperature and pressure, it is found that assumptions of constant heat capacity around introduce serious error. So equation 3.6 into 3.7, and we see that dW is equal to PdV. We know that PdV की जगह पे क्या लिख सकते हैं, माइनस CVdT. Okay, and for the ideal gas equation, PV is equal to RT. That means P is equal to RT by V, and 3.18 becomes P की जगह पे क्या लिखेंगे, RT by V. So dW, that means P is equal to RT. यहाँ पे R और T को हम डिवाइड कर देंगे, that means T and V, dV की जगह पे V. ओके, dV के नीचे V. So that is CV को यहाँ लिखेंगे और dt को T के नीचे लिखेंगे. Why should we do this? Because for the integrating purpose. So minus R CV minus R by CV into dV by V. So that is dt upon T. Now we know that Cp minus Cv is constant R. So that is the put the values of that. So R की जगह पे क्या लिखेंगे, R by CV is equal to what exactly अपन, Cp minus Cv. R की जगह पे क्या लिखा है, लिखेंगे Cp minus Cv. So Cp minus Cv, Cp upon Cv minus 1 is equal to gamma minus 1. શું કરવાનું છે, આ ઇક્વેશન ની અંદર આપણને ખબર છે કે Cp minus Cv is equal to R. હવે આ ઇક્વેશન ને Cv વડે ડિવાઈડ કરો બંને સાઈડ, તો અહીંયા શું થઈ જશે, Cp by Cv minus Cv upon Cv, that is કેન્સલ, એટલે કે 1 અને R, અને R ના છેદમાં શું આવશે, Cv. બરાબર, તો આ ઇક્વેશન ને આ રીતે અહીંયા લખ્યું છે. સો એ ઇક્વેશન ની વેલ્યુ શું થશે એક્ઝેક્ટલી, તો R upon Cv is equal to Cp upon Cv minus R, અને આને કહી દીધું છે કોન્સ્ટન્ટ ગેમા. Cp upon Cv raised to gamma is equal to constant. બરાબર, એટલે કે ગેમા ની જગ્યા પર આપણે શું Cp upon Cv ની જગ્યા પર શું લખવાનું છે, ગેમા. બરાબર, તો એની વેલ્યુ થશે ગેમા minus 1. હવે આ ઇક્વેશન ની અંદરથી 3.20 ની અંદર જે R upon Cv ની વેલ્યુ છે એ શું થઈ છે, ગેમા minus 1, અને એને આપણે શેમાં પુટ કરવાનું છે, ધીસ ઇક્વેશન ની અંદર અહીંયા. બરાબર, તો હવે શું થશે એક્ઝેક્ટલી, તો R upon Cv ની જગ્યા પર શું લેવાનું છે આપણે, ગેમા minus 1. તો આગળ માઇનસ છે, માઇનસ એઝ ઇટ ઇઝ, તો માઇનસ એઝ ઇટ ઇઝ, અને R upon Cv ની જગ્યા પર શું આવશે, માઇનસ ગેમા minus 1 into dV upon V is equal to dt upon T. Okay, give the equation number 3.21. Next, let the pressure, volume and temperature are respectively P1, V1 and T1 in initial state of condition, and then gas and P1, P2 and V2, P2, V2 and T2 respectively for the corresponding value in the final state after the adiabatic process. હવે શું કરવાનું છે, પ્રેશર, વોલ્યુમ અને ટેમ્પરેચરની ઇનિશિયલ કન્ડિશન આપણે લેવાની છે P1, T1 અને V1, અને જ્યારે એની ફાઇનલ સ્ટેજની અંદર કન્ડિશન લેવાની છે P2, V2 અને T2 ફોર ધી એડિયાબેટિક કન્ડિશન. 3.21 ને કયા ફોર્મમાં લખી શકીએ છીએ આપણે, અને ડિફરન્શિએશન કરીએ. બરાબર, 3.21 ને તો equation 3.21 on integrating between the initial and final condition, which is given that, so माइनस गेमा को हम क्या करेंगे, इक्वल टू की दूसरी साइड ले जाएंगे, दैट इज पॉजिटिव. ओके, नाउ यहां पे क्या हो जाएगा, 1 अपन टी है, दैट मीन्स उसका इंटीग्रेशन 1 अपन टी का ln t. तो ln t एंड लिमिट क्या होगी t1 से t2, तो उसकी लिमिट हम पुट करेंगे तो क्या हो जाएगा t2 माइनस t1. ओके, सो दैट इज ln t2 अपॉन t1. इसकी जगह पे क्या आ जाएगा ln t2 अपॉन t1. कैसे आया? क्योंकि यहाँ पे क्या कर रहे हैं, इंटीग्रेट कर रहे हैं 1 अपन टी का ln t की अगर लिमिट करेंगे पुट करेंगे तो ln t2 माइनस t1. ओके, ln t2 माइनस ln t1, सो ln t2 अपॉन t1. सो ये यहाँ पे नेगेटिविटी हम रिमूव कर रहे हैं, माइनस साइन रिमूव कर रहे हैं, तो उसकी जगह पे क्या हो जाएगा v एग्जैक्टली क्या हो जाएगा गेमा माइनस 1 इंटू, यहां पे चेंज हो जाएगा 1 अपन v की, v का क्या हो जाएगा 1 अपन v का ln v हो जाएगा. लिमिट रखेंगे हम v1 से v2 और यहाँ पे माइनस साइन रिमूव करेंगे तो v2 बाय v1 नहीं होगा, क्या हो जाएगा v1 अपन v2. नाउ which rearrange this equation and following relationship between temperature and volume is in adiabatic process. So that should be rewrite this equation. So ln will be cancel. Okay, so t2 upon t1 is equal to v1 upon v2 raised to gamma minus 1. Using this perfect gas law equation, the relationship or the ratio of volume can be eliminated from the 3.20 in favor of the ratio of pressure. So V1 upon V2 is equal to P2 upon P1 into T1 upon T2. Okay. So the resulting expression is that 3.23 is the relationship between the pressure and temperature in adiabatic ideal gas. So T2 upon T1 is equal to P1 upon P2 raised to gamma minus 1 upon gamma. So that's why compare this equation to 23, 22 and 23. So V1 upon V2 is equal to P2 upon P1 raised to gamma minus 1 raised to gamma. And so that's why इसकी जगह पे हम ऐसे भी लिख सकते हैं P1 V1 is equal to P1 V1 raised to gamma and P2 V2 raised to gamma. So that is PV raised to gamma is constant. Okay, that condition we are here completing. So that is PV raised to gamma is equal to constant.